So this is the only new equation. What you need to remember is that this is net force measured in newtons. This is mass measured in kilograms. And this is acceleration measured in meters per second squared. You probably already have that in your notes, but it's important to have it memorized. So what we're going to do on all these questions is we're going to use one of the kinematic equations to calculate acceleration, and then we'll plug it into this equation to get the net force. Starting with number one. So number one, we have the following. We have a roller coaster ride uses magnets to bring a train from rest to 45 meters per second in a time of 7.0 seconds. The total mass of the train and the riders is 5,500 kilograms. Calculate the net force acting on the train. So here's what you got to do. You got to write down all the information that's given, and that information will tell you which equation you've got to use. So first of all, they say it brings the train from rest to a velocity of 45. So V initial is 0, V final is 45. You could write the units if you want, or you can leave them out. It does this over a time of 7.0 seconds, and I'm done. Once I have three numbers, I'll be able to figure out which equation to use. Because we're looking for the equation that has acceleration in it, as well as these three. For example, let me pick an incorrect equation. This equation is not correct because I don't have delta P. I can't use this to get acceleration, so this is no good. What I really want is this. VF equals V initial plus AT. With that, I'll be able to calculate acceleration, and then I'll plug it into my net force equation. So here it is. 45 equals 0 plus A times 7. We'll simplify a little bit. Divide both sides by 7. Oh, I've got the numbers. I don't need my calculator. And that'll get us an acceleration of 6.429. The minimum is to do 3 sig figs, but I'm overachieving today. I want to do 4. Okay, so that's the acceleration of the roller coaster car and the people inside it. But what we're asked for is net force. We're trying to calculate sigma F. That's what net force is. But what do I plug in for M? It's easy. Whatever has kilograms next to it is M. So in the problem it says 5500 kg. Because of that kg, I know that that's the mass. So I'll plug 5500 in as mass. A is the thing I just found, 6.429. Sigma F equals 35360. So, you could write down all of that, but here's what I recommend you write down. If you don't at least write down this, you're being kind of foolish. So here we go. Because I know some people are going to write the whole thing down. Here's what you should write down. You should write down the context, that if this is the problem about the roller coaster. Then you should circle the two equations. Great question. So when you get, if I put the roller coaster question on the quiz tomorrow, you'll look where it says roller coaster and you'll know to use this equation and this equation, and you'll get 100%. Someone is asking in the chat, what's the capital N? That is for newtons. That is just because that's just the unit for force. The unit for force is always newtons. So I got that from thin air. Questions about 1. We'll go on to 2. 2 is, at a circus, a 72 kilogram performer is shot out of a cannon whose length is 18 meters. The performer spends 0.95 seconds in the cannon, starting from rest. Calculate the net force acting on the performer. So, as was the case in the previous problem, we're going to calculate acceleration first. So we can kind of see it in the picture. He starts at rest at the bottom of the cannon. He speeds up for 18 meters, and he has some unknown speed at this position. It also takes him 0.95 seconds to go that far. So here's the information they gave us. They said he starts from rest, so the initial is 0. They say delta P is 18 meters. That's how far he goes. Time is 0.95 seconds. And some people might say this is actually incorrect, but some people might say this right here. Hey, he's moving vertically because he's moving vertically, so A is negative 9.8. That's not true. A is not 9.8 because, A is only 9.8 when it's in free fall. A is only 9.8 when gravity is the only force. So since the cannon is pushing him, he's not in free fall, actually. There's a huge explosion happening, so there's a lot of forces in addition to gravity. Let's see what else. Oh, well, that's it. We're actually going to use the equation that, the incorrect one that I suggested for number 1. The reason we'll use it here is because that's what we're given. We can actually solve for A now. There's our given info. So here it is. 18 equals 0 times 0.95 plus 1/2 A 0.95 squared. This disappears because it's a 0. We'll take 0.5, 1/2 is 0.5. 0.5 times 0.95 squared, that is 0.4513A, and then we'll divide both sides by 0.4513. So that's his acceleration while he's in the cannon. The question is asking us for net force, so we'll plug that acceleration into here. The mass, let's look for the mass. It's the number with kilograms on it, and that is 72. So since there's a kg next to 72, that's how I know that it is the mass. Multiply them together, and you'll have your net force. $2,871. So like I said, this is not graded, so you really don't have to write anything down, but you should. You should write the following. Here's what I would do if I were just eating Pop-Tarts and playing Call of Duty. I would write cannon, and I would write down this equation. I would write down that equation. So if the cannon problem is on the test tomorrow, the quiz tomorrow, you'll know to use this, and then you'll know to use this. you're not really cheating, you're just hacking. Is there a certain amount of sig figs we need to when finishing the net force equation? No, there's at least 3. You need at least 3. The way the system works is you get within 2%. So that's actually, I'm going to go a little further with that. I recommend 3 or more. But here's how this system works. On the quiz tomorrow, it'll take any answer within 2% of this. So 2871 times 0.02, 2871 plus answer. So it'll go 2928. So it'll accept any answer from about 2,813 to 2,928. So you can be pretty far off if you round differently. It's a good question. For those of you just coming in, we're just going over some problems for the quiz tomorrow. We're taking a video, so I got you muted. We'll unmute you later. All right, number 3. Number 3 is car is moving with a speed of 15 when the driver presses the brakes. The car slows down for 50 meters and comes to rest. Calculate the net force acting on the car. So, V initial, let's look at V initial and V final first. Those are good ones to look at. So, it starts with a velocity of 15. It ends with a velocity of 0. So it starts at 15 and it slows and it stops. If it starts at rest, you do these opposite. But here it ends at rest. Without even reading it, I know that delta P is 50 because look at it. The unit is M. So since the unit is M, I know that's delta P. While we're talking about units, take a look at that 1580. I know that that is mass because it has kilograms on it. So let's find acceleration. We'll plug it into the equation that we need. Looks like this one can be used for acceleration. Vf squared equals V initial squared plus 2a delta P. Zero squared equals 15 squared plus 2a 50. We'll simplify a bit. Don't add those. You can't add those because this has a and this does not. So we'll subtract 225 on both sides. You can show that step if you like. Minus 225, minus 225, but it simplifies to this. And now we divide 100 on both sides. So divide by 100, divide by 100. It'll cancel out on that side. And here's our final answer. Well, no, that's not our final answer. That's our acceleration. Negative 2.25. We're looking for net force. So it's the same thing as we've been doing. All we're really doing on the quiz tomorrow is finding acceleration and then using it to find sigma F, net force. So that's negative 3.555. Gotta have the negative. That'll be pretty important. So the bare minimum you should write here. What's your context? What's the problem about? This is about a car slowing down. You should also write down your equation and your second equation. I think a fourth thing to write down, probably this. This is something you might forget. Final answer is negative. So when you're entering it in on the computer, if you have that written down, you'll remember to keep a negative answer. But if you do your work right, it'll be negative anyway. ¿Preguntas? ¿Preguntas aquí? Si no entiendes este problema, tengo en español aquí. Pero la prueba vas a estar en inglés. Okay, I could probably use this page, so. And finally, number 4. Number four. Cuando das un punto now. Okay. When someone throws a punch, the forearm applies the force to the fist. So, if a 0.7 kilogram fist goes from rest to a velocity of 8 in 0.15 seconds, how much force is exerted on a fist? So in order to move your fist forward, how much force are you using? Well, like it says, your fist starts at rest, so the initial is 0. V final is given as 8. So that is like 20 miles per hour. You do it very quickly. So although your final speed is not very high, when you punch someone, you do it very quickly. So you're probably using a lot of force to do it. And we need acceleration to find this. So we'll use my favorite kinematic equation because it's the easiest. We'll use that to get aceleración. A equals 0 plus AT. My work's getting clustered, so I'm going to skip a line. Oh, I forgot to plug in T. So it's actually 0.15. Let me rewrite. You could just erase if you got a pencil. So 8 is 0.15A divided by 0.15 on both sides. You'll get 53.33. Now the reason this number is so big is not because your fist goes fast. It's because your fist changes speed in a very short amount of time. So A is 53.33. We'll plug that into the net force equation. And look for the number that has kilograms. That's how you know it goes in for M. And this 53 gets plugged in over here. So, once again, if you want to be efficient, this is the fist or the punch problem. On the quiz tomorrow, if you see the punch problem, you'll know to use this equation and this equation. And that's about it.